Hi, so a lot of people have been asking how to go around making a hemp plastic. Now, hemp plastic is actually strictly a bit of a misnomer, because they're not really plastic in themselves. What you do is you add them to some kind of resin, and then you let that resin set, and you get a composite panel. Now, most hemp plastics are of that type, where they've been added to an existing resin. If you look online and you see hemp plastics, mostly what you'll see is they're added to standard polyolefin plastics like polypropylene, polyethylene, or some kind of resin, an epoxy resin maybe, or a PU resin, or something like that. But they have essentially been impregnated with some other kind of resin, formed into a panel or object, and allowed to cure, and then these have been talked about as being hemp plastics. So in themselves, the hemp plastic idea is a little bit misleading. It is in fact just a composite, where the fibre being used in the composite material is hemp-based. And I don't think there's anything wrong with that. I mean, we think about those kind of things all of the time, and I don't think, or rather we use those things all of the time, and I don't think that's particularly misleading, although it does make people think of something different to what hemp plastics actually are. So hemp plastics and glass fibre and carbon reinforced plastics are all really of the same kind of family. So if you're going to make a hemp plastic, what are the considerations? Well, it's like any composite that you make. A composite is all about the mixing, the dispersion of the two things one in another, so that you get an even matrix of material and you get that combined effect. Now, hemp as a natural fibre is obviously extremely strong. It has an awful lot of really great properties. It's why they used to make rope out of it, and they make all kinds of things out of it. It's really very strong material. So it's ideal for a composite if you think about it. If you can break up those fibres so that you can get good distribution, then it's actually ideal. Now, my big thing really is biodegradable plastics. So when we made the hemp biodegradable plastic, we didn't use an olefin plastic. We didn't use a polyurethane or a polypropylene or an epoxy resin. What we used was a natural protein plastic, that is casein. Now, this milk protein here is rennet casein. It's produced in mass quantities, incidentally. And for anybody who thinks that using food is a bad idea, because of course milk is a foodstuff, 50% of milk gets wasted before it even gets to the consumer stage, just because it's unfit for human consumption. It's kind of like delay times, washing out the pipes, spoilage, that sort of thing. About 50% is chucked down the drain. If we want to recover that casein from there to use for a plastic, we're basically recovering what is a waste material, and that waste material actually is quite hazardous because we're flooding everywhere with milk which rots and stinks like crazy. So it's not a bad thing to be using milk if we're using that 50% that couldn't be used anyway. So that was my thought process. Now, I'm not sure if that's right or not. I'm just explaining the way I think about these things and why it was that we chose casein. Now, we chose casein as essentially the resin, and hemp as essentially the reinforcement fibre. Now, casein as a resin is really well known. It was called galalith many years ago, and it was used to make buttons and rods and all kinds of material because it was actually a very good plastic. It was thermoset, which led to a lot of problems. It used formaldehyde to cure it because casein will in fact absorb water, and that is an issue obviously in a material that you want to last a long time, that it absorbs the water, it falls apart and it rots. So you needed some kind of curing agent, just like you use in a urethane resin where you use a formaldehyde. And casein used formaldehyde to cure it. That led to lots and lots of problems, that the curing time was dependent on the thickness of the casein, and if it was quite a thick casein, it could take months to cure, and so it fell out of favour, and you didn't see it much for a very long time, particularly when the petroleum-based plastics came in. They were much easier to handle. Galalith just fell out of use, and casein-based plastics weren't used. However, because of the sudden resurgence of interest in degradable polymers and polymers from renewable resources, casein has resurfaced. And the thing about casein is the bulk of the research has been in curing agents that are not formaldehyde based. Now, the curing agent I chose was this stuff. It's tannic acid. Now, I chose tannic acid because it's really well researched, actually. If you go onto Google Scholar and you look at casein, tannic acid, and you put those in the search terms, you'll find tons of papers where people have been working on caseins cured with tannic acid for film formation, for body plastics, all that kind of stuff. A lot of research back up to casein and tannic acid as the curing agent. So that's what we're going to be doing. We're going to be using casein as the resin, tannin to cure the resin, and then hemp as a distributed fibre within that resin to give that resin strength. Now, the tannin doesn't make the casein waterproof, it makes it water resistant. That's actually a good thing, because our world is water-based. Everything requires water. If water can't get into something, then neither can the organisms that eat that plastic. And so a waterproof, 100% waterproof casein plastic would be no better than the plastics that we're using at the moment. They would just be particles drifting in the sea, poisoning everybody. You don't want 100% waterproof casein. What you want is a balance of water resistance to the degree that you want to use the casein. So if you're using casein internally on some of those things that are just crazy that we use plastics for, housings for plug sockets, plugs, knobs, feet, handles, a ton of plastics that we use for no real reason other than they're easy to process and we're used to using them. All those kind of things really need to resist a wipe down with a damp cloth when you wash them. That's about it, really. That's all they really need. But they do need to absorb water when you throw them on the tip, so the bacteria can eat the milk and rot it away. So you always want that balance between water resistance and biodegradability. The more water resistant it is, the longer it will take to biodegrade. The less water resistant it is, the more you have to protect the environment it's in that it won't get wet, but the more readily it will biodegrade. So we have that kind of balance, and it's like everything. Everything is always going to be a balance that you do. So those are the essential components of what we're going to be looking at. And just to review them, hemp fibre is the reinforcement, casein is the plastic resin, and tannic acid as the curing agent that gives a degree of water resistance. Depends on how much tannic acid you put in there. Put a lot in there, very resistant. Not much, not so much. Now we've done a lot of this and made some various bits and pieces. This is a compressed casein handle, actually. It's incredibly strong, and that was sitting in water, a water bath for about 48 hours, and nothing's happened to it. This is a casein plug that we made when we mixed glycerol with it to make it much more plastic, and it's quite bendable and plastic as we think about plastic. This is a casein film that we made with graphene added, and actually it's immensely strong, actually. And this is just a casein blank. I was testing the strength, incidentally, so I've broken the blank. But that was a casein blank where we just added a little bit of tannic acid and tested how strong that was. So that baseline material that I've talked to you about is actually open to an awful lot of experimentation, things that might occur to you. Now, we've added graphene in the order of 1% by weight to see what kind of strength improvement we got. It's not essential to do that. What we're going to go through here is the basic work that needs to be done in order to form that plastic. Other additions that you would do are up to you really to experiment with, and you will add them, or you should add them at the dispersal stage so that you get good even dispersion. And I'll talk about those things as we go through the video. Okay, so let's begin it. The first thing to do is think about the hemp, and I'm going to use hemp, as I say, as the reinforcement material. In order to use it as a reinforcement material, I could use it just as it comes, because there is a company, they're called Eco Composites, and what they do is they make this hemp felt. If we impregnated that hemp felt with our resin and then dried it, we get a pretty tough panel out of that, actually, which is kind of cool. These were supplied by Hemptation and the East Yorkshire Hemp Farm. It's the hemp fibre. It's a very long fibre, it's very tough actually, and we could try impregnating and pressing that into the panels of different shapes if we wanted to, or we could try breaking that up a little bit further, but it's a very tough fibre and it's quite hard to break up actually. This is another thing that was supplied to me by East Yorkshire Hemp Co. It's actually a chopped fibre. I think it's basically the dust off the floor, to be honest. But it's a chopped fibre, and that's much, much easier to break down. So that's actually what we're going to be using. Now, I was sent these things from a Polish farm. I can't remember who that farm was, but it was organised by a friend of mine, a Canadian friend of mine, and she organised this to be sent through. I've tried some of it. It works really well. No worse, no better than the others, incidentally. And this is the raw hemp, where it's just been chopped. So we've got a whole range of hemp materials that we can use in a whole range of ways that we can use them. Now we're going to begin by using the chopped fibre because it's really easy to break down. But you don't need to break the fibre down. And what we would do is make the casein resin and impregnate the resin into the fibre mat. In order to make the casein resin, you do exactly the same that we're doing here, only you wouldn't have the fibre breakdown part. Now I've shown this thing many times because I actually love this thing. This is an Indian spice grinder. It's 2 granite stones with a granite bed that rotate. As this rotates in that direction, those stones are held relative still to this and they turn. Now if I fasten those stones down, what they will do is grind. And if you notice in here we've got a spring, and if I fasten that down there, we get a grinding action. But if I leave that off, then those stones bounce up and down. As they bounce up and down, they're going to pummel the fibre, and it is in fact a hollandering machine. So this will hollander the fibre, and it basically pummels the fibre, flattening it out and separating those fibres out. And in order to do that, I'm going to add 60 grams of my hemp fibre and 2 litres of water, and give that some time just to go around there, binding those and pounding those fibres into individual fibres. Now it usually takes about 12 hours or so to do that because it's quite a slow mechanical process. So I'm going to set that going and leave it alone and let the thing hollander those fibres out. This is the first stage of that dispersion process because we need those fibres hollandered out into a nice stream that we can intermix with. So that's the basic idea here. So very simple stuff. Leave off the screw cap, add your hemp and add your water. There's 2 litres of water here to 60 grams of hemp fibre. Then all we have to do is plug that bad boy in. Okay, so you give it what you think is long enough, and you can tell because it gets kind of even. And all the little sticks that you saw when you first put it in there will be disappeared because they'll have been beaten out into individual fibres and washed through. Now I put 2 litres of water in here. It's probably not enough. You could add more water if you like, but however much water you add, you're going to then have to take it out. But if it does get a bit too gelatinous, then just add more water until you've got it nicely non-gelatinous and all those fibres are sloshing around in a mass of water, which is what you want. You want them to separate. Once you feel they've separated enough, we're going to add the casein. Now we had 60 grams of paper. Okay, so that's had quite a while churning. Now you can tell it's ready because it goes kind of gelatinous really. All those fibres get separated out and get into the wash water. Now I added 2 litres of water here. If you're finding it getting a bit too gelatinous, well just add more water. You've got to keep it so it's nice and liquid and so those fibres get separated easily. Any water you add, you're going to have to take out later. So don't add tons and tons of water, just add the water that you need. Now when you feel that those fibres are separated, and you can tell because all the sticks that you saw in there when you added the hemp have gone. It'll all just look like a smooth, even, jelly sort of paste. When it's at that stage, we want to add to the casein. Now we added 60 grams of hemp in here, and in here I've got 60 grams of rennet casein. That really is just a random guess. It's something to play with. Have a play with those ratios because that will alter the quality of the material that you're making. And there's an awful lot of things that you can experiment with here to get better stuff than I'm doing. I'm only giving a groundwork. It's not a finished product. It's one of those things that you will need to do work on. And those ratios of hemp to casein are one of the essential things really to be playing with. Now casein, when it's like this, is like a tight ball of protein. So we add it here, all that will happen is those balls will go in between the paper fibres and stay as balls, and that's all that happens. Unless we add this stuff. Now this is 4 grams of potassium hydroxide in 200 millilitres of water. What happens then is that those bundles of casein will open out into fibres. And as we continue mixing it, those fibres will intermingle with the cellulose fibres that we've put in. Now, you don't need to add the cellulose fibres. If you just want to make the casein, then you would just add the casein to the water and the KOH to open them out. Then we would add to the linking agent, which is the tannic acid, and we'll come to that later, and then we would drop the casein back out again. But here, because we're making a composite material, we want to entangle over all of those fibres. So, like I said, the first thing to do is add the casein balls to it, then add the KOH to open those up into strings, and those strings along with the hemp fibres are going to intermingle as they continue mixing. Now you need to give that a fair amount of time for that to happen, a couple of hours or so. Again, you can look in on it because you will find it going even more gelatinous, and if it's getting too gelatinous, add more water. By the way, we have to add the KOH as a solution. You drop the bits in there, it'll ruin everything, so make it a solution first. Okay, so it is a slow and noisy process, but this has been going for a few hours now, and that makes everything mix up rather nicely and makes all those fibres interlink with all the protein fibres. What we're going to do now is cross-link them. In order to cross-link them, then we use this stuff. This is tannic acid, and it's dissolved in a KOH solution. Now there's 6 grams of tannic acid in there, and that's 10% by weight to the casein that we put in here. It's quite a lot. So if you use less grams, like 3 grams, 2 grams, 1 gram, you won't get as much cross-linking, and it will be more permeable to water. If you use more, like 10 grams, then you get an impermeable plastic at the end of it. There is a limit to how much you can put in because some won't cross-link. But that's the tannic acid. It's this kind of brownish powder. It looks like dried tea, actually. And it's dissolved in 200 millilitres of water with 2 grams of KOH in there to help that dissolve. So that's now dissolved nicely. I'll be turning this back on and I'll pour that in. Now, as I said, it is a time-consuming process because we gave this a long time to Hollander those fibres out. A couple of hours to open up the casein and mix the casein ink in there, and now we're going to pour that in and give it 12 hours. So when you're doing a small batch like this, you can really expect it to take a day or two in order to do it. Anyway, let's add the tannic acid and just leave it alone for 12 hours. Okay, so that's it done. Now just to warn you, I am shortening these timelines a little bit because it obviously takes a couple of days to do and I'm doing it in one video shot, so I have shortened them a little bit. This has only actually been turning for 2 hours instead of the 12 hours that I think it should have. But it's done a relatively nice job, and when we look in it we can see it's quite gelatinous with some fibrous throughout. Now one of the reasons it takes so long is to mix it with the hemp fibres that we put in there. If all you actually want is the casein, then just leave out the hemp fibres. You put the water in there, you add the casein, you add the KOH, add the tannic acid, give it about 12 hours to mix, and then proceed from there with what we're going to do. If you want the hemp version, then obviously put the hemp in first and Hollander it, and then continue on from where we added the casein. You'll notice I'm being actually quite generous with the water, and you can be because you're going to remove it all. Now this is pretty alkali at this stage, so you will note the gloves. those who are not used to handling these kind of chemicals, who want to be more aware of splashes, you probably need to wear an overall or maybe an apron, your safety glasses and your gloves. So that would be the kind of equipment that you like. Now I'm going to pour this container into this container, and I don't intend on holding that up to do it, because that would be stupid, because that's holding it up to where my eye level is, and I don't plan on doing that. So I'm going to pour it down here and then lift it back onto the bench. And there it is. Now everything's nicely mixed in there, and remember that casein has opened up into fibres now that have been cross-linked by the tannic acid we put in there. Now what we want to do really is to make those casein fibres close back up again, and when they close back up, they'll close back up around the hemp fibres and they'll be linked. So this stuff will aggregate and sink to the bottom. Now it's only going to do that in an acidic solution, so we have to acidify that solution. Now there are lots of acids you can use. You can use the strong mineral acids, or you can use the weaker organic acids, so things like a vinegar, acetic acid. I'm going to use hydrochloric acid. This is 37%. It's a brick cleaner, and I've pre-mixed that here in a 1:5 ratio. There's 50 millilitres of hydrochloric acid. And we add that to our alkali solution to neutralise it and acidify it. Now we're adding an acid to an alkali, so don't chuck the whole thing in there or you really will be sorry. And as it gets acidified, you should be able to see that it's beginning to agglomerate, which is kind of cool. See that? It's going from the brown colour, which was a tannin, to this kind of whitish colour, and that whitish colour is where the casein is curling up around the hemp fibre. So I mixed up 250 millilitres of acid solution with 50 millilitres of concentrated hydrochloric acid in 200 millilitres of water, and I've used about 50 millilitres of that to get this. Now all I have to do is leave that to settle. Now we can filter it at this stage, it'd be quite a deal quicker, but I'm going to leave it to settle a little bit and go and grab a cheesecloth, because right now that stuff is clumped together and will in fact just go through a cheesecloth. I have given it just a little bit to agglomerate, and you can probably just see that agglomeration. It's around about there where it's beginning to separate out. I did say you could use a cheesecloth for this, and that is one way of talking about it. This is just a bit of net, and if I pop the bit of net in there, I can pour that into my net. And it's almost like a curds and whey kind of thing going on. And if we pick that out, you can see that we're getting a liquid there in the bottom as it all just drains out. There we go, a nice clear liquid draining out. Now there will be some fat and bits of wasted material in there, which is why it's kind of a yellow colour. The more brown it is, then the more tannin that you've lost. So having that yellow colour is telling me that it's losing fat, but quite a lot of the tannin has cross-linked in with the casein there. And all I'd then do is just leave that to drip, obviously. Now, at this stage, if we wanted to have a plasticizer, so something like polyethylene glycol or glycerin, something like that, it's at the mixing stage before you add the tannin that you would add the plasticizer. Now, we did a method of making graphene using glycerin and the upright ball mill, if you remember. It's an earlier video. That's an excellent way of getting graphene and plasticizer into this, because you don't have to wash the graphene out of that. You can just use that directly in here, adding at that point, like I say, just before you add the tannic acid, you add the glycerin and graphene mix in there, and then you will get graphene filled plastic. If you want to add a pre-prepared graphene, where you've got a dry graphene already available to you, you bought it from somewhere else, like us for example, then again at that powder stage, when you're adding the casein, you would add the graphene then, because this is all about dispersion of materials. That's all it is. All we're doing is taking those materials and dispersing them well one into another. And it's at even dispersion where you get good composites. So that's all we've actually done. Okay, so that's a lot of water that has been removed from there, as you can see. And what we're left with is our residual solid. And there it is. Okay, let's move that out of the way. There is our casein, hemp and tannic acid plastic. All we do with that now is dry it until a powder. Now you don't want to dry it as a solid lump like this, because it's a nightmare to powder. Let that get a bit drier and then chop it up into small bits, maybe with the blender. I actually use a pasta maker or a mashed potato machine that pushes this through. That helps it to dry, and it will dry in little lumps that are then much, much easier to powder. And what we have here is an example of the powder. And actually, I'll take that off because it'll just stick to my glove. And that's what the finished powder looks like. Now, that is casein and hemp plastic. There is graphene in that one, I think, because it's such a dark colour. And all we have to do with that is heat it and extrude it, or put it in a press and give it some heat and some pressure, and we'll get our plastic parts. Anyway, what I'm going to do now is finish this, get the potato masher, extrude it a little bit so you can see what I mean by that, and that's really the end of the video. So let's do those bits and wind this up. Okay, so I was trying to find or think of ways of improving this actually as we're going along, and in the end this is what I did. I put it back into the cheesecloth and put it into the press, and it formed this drier cake. A lot of moisture came out, and when you saw how much water we were using, we want a lot of moisture out because it shortens the drying time. Now this is a kind of a mid-damp stage. It feels sort of dry, but it isn't. It's still quite moist, and we don't want to let it dry like that, because if you let it dry like that, it'll be next to impossible to do anything with it. What we need to do is get into a kind of breadcrumb style. So this is it. This is where we've got it into a nice light fluffy breadcrumb. When that dries, we can use that as the resin in our moulds. Now it'll stay like that forever, really. I mean, it is milk, so it will rot until you finish the curing process, but pretty much it'll stay like this nice dry crumb. When it's thoroughly dry, then we can put it into a press. Remember, when we press this stuff, we apply heat and pressure, and that's how we form these kind of rigid waterproof materials, and that's what we're going to do with it later when we finish this process. But I wanted to show you that so that you understood or had at hand everything you need to make this casein-based plastic, which has been cured by tannin. And as I say, the milk itself, or the casein, is the resin. What we've done is finely distribute hemp fibre throughout it. And there is an option, obviously, of adding the graphene, as we discussed. And there's other fibres you could certainly add in there, and other materials you could do this with. There's just lots and lots of scope in order to be able to make this as a plastic engineering material that will rot away when it's in the environment. Now, to get that crumb, all I did was put it in a blitzer. And we don't want to blitz it for absolutely ages, because we'll just kind of force it into a big lump again. We just kind of want to blitz it off and on until it forms a breadcrumb. And you can see that it's done that in a few seconds. If we pour that out, there's our nice breadcrumb mix. We get a lump there, incidentally. Run your fingers through it, make sure it feels like breadcrumbs. Got a couple of lumps, let's just stick them back in there again. There we go. Okay, so that is all there is to it. That's how we make a hemp reinforced casein based plastic that has been made water resistant through the use of tannin. I hope that was of interest to you. I thought I would go through it. It will be a long video, I appreciate, but there is plenty of experiment to do to make this your own. That is just the basics of what you need to do. You could leave the hemp out and have a casein resin, you could put graphene in there, you could put different fibres in there. You don't need to beat the fibres of the hemp out, you could use the casein resin to impregnate the hemp and then cure it by pressure and heat. So that is the basics. Lots of things to do to make it your own. I hope it was of interest. Thank you very much for watching.